I want to pull you through one more problem with just solution concentration, and we're going to have to visit what mass percent is. Mass percent of a solute would be mass of that solute, we'll call it component A, okay, divided by or per 100 grams of the mixture. In this case, the mixture is the solution. Okay, so that's the definition of the mass percent of a solute in a solution. And it goes hand in hand with just basically taking a specific situation of mass of a component in a mixture. So the problem we're going to work is this one. And I think I'll go ahead and just kind of squeeze in the upper corner there a little beaker, and we'll go ahead, and I don't know if you can make this work, but we'll kind of say what's going on. So this says we're going to put 46.87 grams of isopropyl alcohol. What, maybe envision that. What do you think? What is that, a liquid, solid, or gas? Yep, I'm guessing it's a liquid. So we're going to put that amount of liquid, 46.87 grams. I usually abbreviate isopropyl alcohol as IOH. I guess it just kind of goes back way back when I kind of learned sort of these things. So isopropyl alcohol, or IOH, that is our solute. And it says that you're going to dissolve it in water, and that the volume of your solution, that would be your isopropyl alcohol plus your water, is going to be 300 with a decimal there, so that means 3 sig figs, 300 milliliters of solution. And let's see, we have a few things listed down here. First off, it says calculate the molarity. Well, what is molarity? Molarity, capital M, that's going to be what? The moles of IOH per liter of solution. Okay, so do you see where the moles of the isopropyl alcohol we can get from the grams of IOH? And what do we, I'm laughing because I keep asking this question, what do we use to go between grams to get to moles? Of course, we use the periodic table, and we calculate the molar mass of isopropyl alcohol. We can do that because we were given the formula, C3H7OH. Let's see, and then we're just going to have to divide by the, we want to get liters of solution. Well, we don't have liters of solution, but we have milliliters of solution. So we're going to put that in the divisor, and then we're going to have to convert from milliliters to liters, and then we'll have molarity. These next two kind of go together. It says, what additional information, if any, would you need if you wanted to find the weight percent or mass percent of alcohol in the resulting solution? And I'll give you a hint. Here's the symbol. It looks like it is the Greek letter rho. What is that the symbol for? That is the symbol for density. If we know density, we can, I'm going to show you how we use density then to knock out the weight percent. So the density is given down here in part 3, 0.975 grams of solution per 1 milliliter of solution. We're going to use that to our benefit. All right, so let's work this problem. We're going to go for the molarity first. And so, like I said, we're going to use that mass of isopropyl alcohol, and we're going to convert it from grams to moles using the molar mass. Are we okay with this? That first term is relative to the carbon. The second term is relative to the hydrogen. The third term is the amount of oxygen. My pen died for a minute. Okay. Cool. All right, so we're just going to go ahead and knock out this problem. I'm going to do it in one fell swoop. Now, if you wanted to do a side calculation where you took this mass and this molar mass and got moles, you could do that kind of separately and then divide it by your volume. But notice that I'm going to go ahead and take the mass divided by the volume. Now, what term, I think I did it this way, I'm pretty sure. How can we use the molar mass right here to get grams of isopropyl alcohol to cancel and be left with moles? Yep, we're going to use it just like this, what I call the flipped version of the molar mass. And you see where that actually came from this, right? I really discourage you to kind of do the G/mole. You really, I think, need to be writing it this way: 60.09 grams of IOH per 1 mole of IOH. And then when you do that, you're like, oh yeah, I know. If I want to put it here, I'm going to have to flip it in order for my grams to cancel, be left with moles. So anyway, with that second term, it's looking like our grams cancel. We have moles of isopropyl alcohol per milliliter solution. We're close. How do we go ahead and get milliliters of solution to cancel on the bottom, be left with liters of solution? What does that look like? It looks like this. We're going to put the milliliters on top, 1,000 milliliters on top, and 1 liter in the bottom. So, you know, if you're keeping track, to me, it's looking like we have units of grams cancel, milliliters cancel. We have units of moles per liter, which is perfect. That's molarity. So we're going to round this according to sig figs. How many sig figs we going to leave? I'm liking 3 because I got 4 sig figs up here, 4 sig figs here. There's no uncertainty brought here. And remember, this is 3 sig figs because there is a decimal there. So the molarity rounded to 3 sig figs is 0.260. Now what I would probably do is write 0.260 molar isopropyl alcohol. That's probably what I would do. But this is the more explicit way. Okay? Oops, did I say 0.260? Sorry. My bad. 2.60, final answer. Okay. Now let's see what we can do with that second problem, actually kind of the second and third. So, yes, we can go ahead and go to weight percent if we know the density. And I really encourage you to go ahead and when you unpack this density, do like I did before. Density is equal to, it's relative to the whole solution, so it's 0.975 grams of whole solution per 1 milliliter of the whole solution. Now our target here, sometimes this is a good one to say how we're going to get the target. Well, our target is mass percent isopropyl alcohol, so what would those units be? So that would be grams of IOH per 100 grams of solution, right? Okay. Well, actually, it's not going to be too bad because the previous slide, what did we do? We started out with the grams of IOH, it was given in the problem, divided by milliliters of solution, that 300 milliliters of solution. Do you see where, I'll draw your attention up here, I can actually go ahead and use density, put it here, okay, and somehow make those milliliters of solution cancel, be left with grams of solution. This is what I was trying to say. So this was our original information given the problem. That's that mass of isopropyl alcohol that's dissolved in that total mass of solution. Now do you see where, what term would come next using density to have milliliters of solution cancel? Well, it'd be the flipped version of density, wouldn't it? So there's your density, 0.975 grams of solution per 1 milliliter solution. We want milliliters of solutions to cancel. At this point, notice we have grams of isopropyl alcohol per grams of solution. And then, so to get it per 100 grams of solution, we take it times 100%. So that would give you actually your mass fraction times 100 is your mass percent. Okay, I didn't talk much about mass fraction, but remember, all mass fraction is the mass of your component per 1 gram, and mass percent is the mass of your component per 100 grams. Okay, kind of scales it up. Very good. Okay, just to kind of summarize, this is what we came up with. So here's a couple problems related that you're going to be pulling in mass percent in as you work the problem.